Welcome to our next complex numbers video, our second video on actual complex numbers. Now, a complex number is a number that's written in the form of a plus or minus b times I. We have a real component and an imaginary component. All right, well, let's get into example one. Whatever you can do with real numbers, you can do with complex numbers. You can add, subtract, multiply, divide, and whole lot. So let's get into how to add complex numbers. If w is a complex number, which is 3 plus 5i, and z is another complex number, which is 7 take away 2i, let's calculate w plus z. Let's add the two complex numbers. All we do is add up w plus z, and to do that, we add the real components. 3 plus 7 is 10, and then we add the imaginary components. 5 take away 2i makes plus 3i. Right? How about subtracting? Let's subtract complex numbers. So we want to subtract w away from z. Z take away w. So let's write down z and subtract w. And I like to put brackets to keep track of what's going on with our negatives. So once again, we subtract our real components. So 7 take away 3 leaves 4 real. And now we've got to go negative 2 to subtract 5. Negative 2 take away 5. Now be careful, negative 2 take away 5 is negative 7. So that leaves us with minus 7i. All right, well, we can do fancy stuff like calculate 2 lots of z plus 1 lot of w. So let's go. 2 lots of z, so 2 bracket z plus w. Now, we're going to multiply this out like we do with brackets. So we're going to go 2 times 7 is 14. And 2 times negative 2i is negative 4i. That's 2 lots of z. And then we're going to plus on w. So let's again add the real part. 14 plus 3 is 17. And negative 4 plus 5i. Negative 4i plus 5i is going to be positive 1i. But I'm just going to write 17 plus I. Either of those are acceptable. All right, well, we can add and subtract and do fancy stuff. We can also multiply. So let's show you the trick to multiplying complex numbers. We're going to multiply w by z. So let's go. We're going to write it out as w, put it in brackets, times z, don't need the times sign, times z. Now, it's like a quadratic, and we're going to treat it like a quadratic. So let's start multiplying out like it was a quadratic. Let's go 3 times 7, which is 21. Now we're going to go 3 times negative 2i, which is negative 6i. Now we're going to go plus 5i, or just 5i times 7, which is plus 35i. And then we're going to go 5i times negative 2i. Now 5 times negative 2 makes negative 10. And I times I would make I squared. So we're going to get negative 10i squared. Now, we can simplify these two bits in the middle. If we have minus 6i plus 35i, we have plus 29i. Now let's turn our attention to the I squared. And remember, in this whole process of complex numbers, mathematicians have defined I squared to be negative 1. That's the key part of complex numbers. I squared is equal to negative 1. So what we can do is take I squared negative 1 and replace this I squared with negative 1. Now don't go minus 10 minus 1 because it's minus 10 times I squared. So it's going to be minus 10 times negative 1. Now don't forget two negatives. Negative 10 times negative 1 makes positive 10. So we're going to write down 21 plus 29i plus 10. And now we can quickly add up the remaining real bits. 21 plus 10 gives us 31 real bits and 29 imaginary bits. So our final solution is 31 real bits plus 29 imaginary bits. Right, that's us for the video. Thanks so much for tuning in.